Hello, ladies and gentlemen. We are now starting Unit 2, which is conics, parabolas, circles, and more notes. All right, so it's a lot. We've got 10 lessons. Our first lesson today is going to be a prerequisite lesson on completing the square. So completing the square is a pretty significant piece of the first couple of lessons that you're going to have to use. You won't have to use like a full solving of completing the square, but setting it up. So what I thought we should really do, and there's your standards page, what I thought we should really do is just go back and go, how do you complete the square? Like, how does that work? Instead of kind of jamming it into lesson 2 and 3. So that's where we're going to begin. All right, so today is just completing the square. So in order to do that, you need to know like what exactly is a perfect square trinomial. So we're starting right here, right? What is a perfect square trinomial? And a perfect square trinomial is a trinomial from a squared binomial. So it's the result. This trinomial is a result of a squared binomial. So like here is a binomial squared, right? X plus 3 squared. So there's a squared binomial. The trinomial is the result of after you multiply that. And remember, oh my goodness, please do not just distribute that 2 and say it's x squared plus 6, or plus 9, because it's not. Remember, when you solve these, it's x plus 3 times x plus 3. And that's what we get, right? We use the area model or FOIL or whatever you want to use, okay? So what I did was just to kind of get you into the mode is I said, now let's kind of work backwards and rewrite the following standard form quadratic expressions as perfect squares. So these basically are perfect square trinomials, right? So we've got 3 of them, okay? And I want you to put it in factored form. So how I know it's a perfect square trinomial is that these, where you multiply, right, are all perfect squares. And you're looking for a number that multiplies to be 36, which is 6 and 6. And then they also add to be that number. So when I go to factor them, I could say x plus 6 times x plus 6. Okay, I could write it like that, which again, those two numbers, 6 and 6, multiply to be 36, and they add to be 12. I'm not going to write it that way. I'm literally going to erase, if I can find my eraser. I'm literally going to take x plus 6, and I'm just going to square it. But that's a perfect square trinomial there that is now factored. And it is from a squared binomial, right? A binomial multiplied by itself. Okay, so for the second one, again, we got a 36, but we got a negative 12. So you're going to take an x minus 6 times an x minus 6, right? Because x minus 6 times x minus 6, the two negative 6's multiply to be a positive 36. They add to be a negative 12. Last one you do. Go. I think. Well, multiplies to be 100. That also adds to be 20. Same number. And I bet you have it. X plus 10. Yeah. Okay. All right. So what is the pattern that occurs with those trinomials? Well, the C value. Okay, now remember, let's talk about format for quadratics. That's the C value. This is the B, and that's the A, the numbers, right? That whatever's attached to that AX or that X squared. So in this case, these were 1s, right? The B in the first case was 12, the second case was negative 12, the third was 20, and the C's were 36, 36, and 100. Okay. So what occurs? What pattern that occurs with these trinomials? The C value is I'm not gonna write it out. Perfect square. And the B value is the square root of the C value doubled, or times 2. Doubled. We're going to say doubled. Okay? So think about how that works, okay? So we'll go back to 3. The C value is 100, right? That was a perfect square of 100. And the B value was the square root of that, so the square root of 100 is 10, right? And then we took that 10 and we doubled it, and that's how we got the 20, okay? All right, so solving an equation involving a perfect square trinomial. Okay, so I'm kind of walking you through these a little at a time. 4, 5, 6, and 7. What we're doing with these is we are saying, okay, oh boy, my numbering, just so you know, I just know this is really messed up because I cut and paste some stuff. Okay, don't worry about the numbers. Just go to this section. Solving an equation involving a perfect square trinomial. So when I go to 4, I see on the left-hand side, I see a perfect square trinomial. I see an x squared minus 14x plus 49. How I know that is that this is the perfect square, right? Which is square rooted is, the square root of 49 is 7. And then 7 and 7 make 14, but it's a negative 14. So I'm going to say this is x minus 7 squared. Okay, do you see that? What I'm saying is like I wrote perfect square trinomials here. These are perfect square trinomials, and I want you to factor it. And then if you remember when we did these way back when, is to solve, like let's say I want to solve for x, I would take the square root of the left and the right side. And the square root, I take the square root because I have a squared here. And the opposite of squaring is square rooting. So I would square root it, and I would get x minus 7 equals, now I have to have a plus or a minus because when I square root 81, I have 9. And that means that negative 9 squared could be 81, and also 9 squared could be 81. So I have to consider both options. And then because I have a negative 9 and a positive 9, I separated at this point. And don't stress if you don't remember all this, because we're going to do, like, you're going to see it a number of times, like when we actually get into this unit, it'll come back. The more that we're doing this, it'll come back. So then I solved, sorry, I sidetracked. And then I've got 2 answers. I got when x is negative 2 and then x is 16, okay? Now that turned out because 81 was a perfect square. Not always the case, okay? So let's look at 5. All right, so we look at 5 and I go, all right, I see a perfect square trinomial. 16 is a perfect square, and the square root of 16 is 4, and 4 plus 4, or 4 times 2, right? 4 doubled is 8. So I know that that factors to be x plus 4 times x plus 4, or x plus 4 squared. There's my perfect square trinomial again. And when I do that, I see that, I go, okay, I've got that squared, so I'm going to undo by square rooting. So that takes care of that squared. And then I got this hot mess here. I got 32 is not a perfect square, like 81 was on the other one. So I got to simplify. So this is something we're going to work on throughout this unit as well. So you take a radical, and to simplify a radical, you look for a perfect square that is a factor of 32. So 16 times 2 make 32. And 16 is a perfect square. So I put them in their own little radical worlds because I can separate them like that. And it still means they would typically be multiplied, right? So radical 16 and radical 2 equal radical 32. And I square root 16. So the square root of 16 is 4. Okay. So now I have an irrational number on that right side. So I can't do anything besides minus the 4 to solve for x. And then I literally have negative 4 plus or minus 4 radical 2. And that's it. Like that's all, that's my answer. So I know it kind of looks funny, but that's an irrational solution. So that means that, that there's 2 of them. There's a negative 4 plus 4 radical 2 and a negative 4 minus 4 radical 2. Okay, So to save time, like there's 6 and 7 is not bad, but it's something that once I put it on here and I printed it, I was like decided that we're gonna hold off because you're gonna see one on the back page and I don't think you want to want. Okay, so now think about what I just did. I showed you perfect square trinomials and we factored them. I showed you an equation that already had a perfect square in there and we solved it. Sometimes, and this is the big piece, okay? The big piece for what we're going to do tomorrow, and the lesson tomorrow, is we're going to actually create, using circle formulas, we're going to have to create circle formulas. So we're going to have to create perfect square trinomials. So this 3 right here is the key. You have to be able to come up with a perfect squared trinomial. If I give you an x squared and a plus 10x, or for 7 here, an x squared minus 18x, and then x squared plus 20x, okay? So to do this, your step 1 is you're going to divide the b value by 2, okay? And then, so it's b divided by 2 like this. And then you're going to square that answer. So b divided by 2 squared. Okay? And add to the quadratic. All right, so I'm just asking you to create them. Okay, so 6, 7, and 8 again. Same numbers. You get the idea. Okay, these 3 examples down below. Okay, we're going to take this b value, right, which is 10. I'm going to do those 2 steps. I'm going to take it first and I'm going to divide by 2. And I want you to show this. 10 divided by 2. Don't just skip this step. I want to see a 5 there, and there's a reason in the back why. And then I want you to square that, and that's 25. And that, my friends, is what I'm going to add here. And you just created, like the ones I already showed you up top, you actually created a perfect square trinomial. You made that. Okay, now, so if I could factor that, and it would be x plus 5 squared, right? Because 25, the square root of 25 is 5, and 5 plus 5 is 10. So that's your perfect square trinomial. Okay, it is one of these, right? It's one of these guys. So you're going to be in charge of making them using these 2 easy steps. Okay, so we're going to do it to our 7 here. Negative 18. Right, there's your b value. I'm going to divide it by 2. I'm going to see negative 9. I want to see negative 9, and then I want you to square it. And a negative times negative, this is always going to be a plus 81. Did you notice that I already put the pluses here, right? I did that because it's always, when you square a negative, it's always going to be a positive. So you're always going to say plus whatever that is, okay? And last one, you do it. Go, 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 go. You should have gotten 100 here, right? 20 divided by 2 is 10, and then you square the 10. I don't know why I always put it down. Okay, back page. Using completing the square to solve an equation. Okay, so now this is where we're going to take it tomorrow. But we're going to go, like, the weird part about tomorrow is you're not going to actually solve, but you're going to set it up using completing the square. You'll see when you watch the video. I don't know why the steps got cut off on this, but okay. So, using the following steps to solve the quadratic by completing the square. So I've got a quadratic, and if you notice, it is not factorable, and it's not a perfect square, right? It's not a perfect square trinomial, meaning that, like, so yeah, that negative 4 is a perfect square, right? But it doesn't, so the square root of 4 is 2, but 2 and 2 do not add to be 8, okay? And there's another big piece. Remember I had said, remember how the C values are all positive? There's a positive, 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 right? These were all positives because I had told you a perfect square trinomial is where that C value is the B squared. When you square a negative, it always becomes a positive. So the big key here too is that C value is not positive. All right, so we're gonna solve by actually doing completed square. So it says step 1, if necessary, make the a value equal 1. So okay, I got an a value of 1. I actually didn't throw any of those in for your homework either. I wanted you to just focus on the steps, and I didn't really do step 1 with you, but that is true. Like, you can't do completing the square unless the a value is 1. Step 2, move the c value to the right side of the equation. So when I say move, we're going to do the opposite to get it to the other side, right? And that's going to be 4 here. You know what? No, I'm going to do what I just did. I'm going to leave that. What pink did I click? Okay. There we go. All right, so step 3, divide b by 2 and square it. So that's just like the steps you did on the other side. So I'm going to take the b value, which is 8. I'm going to divide it by 2, which is 4. This number right here is crucial. I need that number. I need that number. I'm going to square it, and I'm going to get 16. Okay? And then add that number to both sides of the equation. So I'm going to say I'm going to add that 16 to both sides. Okay? So just like so. So now, look what you just did. You created a perfect squared trinomial on the left side. That x squared plus 8x plus 16 is a perfect square trinomial, right? What multiplies to be 16 that adds to be 8? And guess what? Peeps, that's here, right here, that number, this number right there, is always going to be right there, right? Because x plus 4 times x plus 4, think about it, 4 times 4 is 16, 4 plus 4 is 8. There's your perfect square trinomial. Okay? And then you're going to do just what we did on the front. You're going to square root. Notice I put that plus minus. Perfect square, 20 is not a perfect square, so I got to find a perfect square that goes into it. So 4 times 5, the square root of 4 is 2. So I'm simplifying that radical. We will have many opportunities over the next couple of times to do that as well. So, and then negative 4 plus or minus 2 radical 5. Okay. All right. Let us do 5 and 6. My goodness gracious, I've got another 5 and 6. These numbers, peoples, are all over the place. I apparently did not check the numbers. Okay. Oh, I did give you one. I did give you one for the start here, where step 1, if necessary, make the a value equal 1. Okay. So the a value is not 1. I'm going to divide all by the number 2. I'm going to divide it out. Now you're going to see at some point that may not always be effective to completely divide it out. It's another discussion for another day. You know what I'm going to do? I'm going to add some space here, because this is what I got to get. I got to get a perfect square trinomial here. Okay? So the c value is already to the other side. I'm going to take the b value, right, divided by 2, and then I'm going to square it, right? So my 16 divided by 2 is 8, and I'm going to square that, and I'm going to get 64. That 64 is what I add to both sides, right? And then, because remember, here's that 8 always dumps back in here. Because what multiplies by itself to get 64, 8 times 8, what do you add to itself to get 16? 8 plus 8. So that's why it's a perfect squared trinomial originally, is because this number. And then 36 plus 64 is 100. Ooh, I got a nice pretty one, right? Because I can already tell that's a perfect square. Right? And then I'm going to square root to solve. To get rid of this squared, I square root. I have a plus minus 10. And then because this is, right, a 10 and negative 10 and positive 10, I can add. we can separate it. So we're going to say 10 minus 8, negative 10 minus 8. So I get x equals 2 and x equals negative 18. And there is my two answers. So those are my two answers. All right, now 6, this last 6 is all kind of moved around. We got to fix that. We're going to first minus the 4x because we got to get the a and the b on the one side, and we got to get the c to this side. So I'm going to do x squared plus 2x. I'm going to leave a space because I'm going to do my completing the square, negative 5. Okay, so we're going to do a little faster. B value divided by 2, square it, is 1. Add that to both sides. Perfect square trinomial. X plus 1 squared, right, equals negative 4. Square root. Oh boy. Square rooting a negative. Can we do that? Well, up until this year, we always said no, but guess what? We're something going to be I'm teasing you, something coming up called imaginaries. We are totally going to be able to do that. Okay? So I'm not going to stop us. We're going to do this. For now, we're going to solve it, and it's going to look like that. Okay? So that's not a real number. It's an imaginary, and it actually comes to be 2i, but you're going to learn that. You'll learn that this unit. We're going to do imaginaries, all sorts of fun stuff there. Okay? Hopefully that was a good review for you on completing the square. So go do your homework, and the next day is lesson 1. We'll get into circles, domain, and range, and we'll be using this, okay? All right, folks. Talk to you soon.